This viewer's question goes as follows. Suppose we have demand given by 400 minus 4p, and we have supply given by negative 200 plus 6p. The first part of the question given to the viewer was pretty straightforward and just said, find the market equilibrium, which he already did, presumably by setting quantity demanded and quantity supplied equal to one another, because that's the condition for equilibrium, and then solving algebraically for the equilibrium price and quantity to get a price of 60 and a quantity of 160. Graphically, that just looked like if you had a very basic supply and demand diagram here, your equilibrium price would be at 60 and your equilibrium quantity would be at 160. So far, so good. However, the viewer's question also asked, what is the elasticity of demand at this equilibrium point? The viewer then got confused and said, well, I don't really know what to do here because I've always been told that elasticity was between 2 points and the equilibrium point is only 1 point, so how can I approach this problem? The viewer's thought was that he would just take a point somewhere near the equilibrium on the same demand curve here, maybe just arbitrarily increase or decrease the price a little bit, figure out what the corresponding quantity demanded would be in that case, and then calculate the elasticity of demand between those 2 points. Price elasticity of demand, as you recall, is the percent change in quantity demanded divided by the percent change in price. If you remember, we always take the absolute value of that, so we always report price elasticity of demand as a positive number. Now, we could do that, and it'll give us an approximation of price elasticity of demand. But we can do a little bit better if we think about what price elasticity of demand actually means. So here, we said we're talking about a relative or percent change in quantity demanded and a relative or percent change in price. So just doing a little bit of algebra here, we could restate this elasticity of demand as the absolute value of the new quantity minus the old quantity divided by the old quantity times 100%. That's just the definition of percent change. All divided by the new price minus the old price divided by the old price times 100%. Or we could just notice that mathematically these 100% are going to cancel, and we can just represent the new quantity minus the old quantity as change in quantity, and the new price minus the old price as change in price. And we can in fact say that elasticity of demand is just the change in quantity divided by quantity, all divided by the change in price divided by price. And of course, we're reporting the absolute value. Now, this setup is useful because we can manipulate just a little bit to get something that actually relates back to our demand curve. So we could say here that our elasticity of demand is just the absolute value of the change in quantity divided by the change in price times price over quantity. Just taking this price here and realizing that dividing in a denominator is actually multiplying, and then taking this quantity here and just realizing that it's down here. Just a little bit of simple arithmetic gets us from here to here. It's helpful to have elasticity of demand in this form because you'll notice that we can actually go about filling in all of these quantities, specifically at this equilibrium point. The way we've defined this here, we no longer have necessarily an old and a new, even though it's sort of encapsulated within this change in quantity divided by change in price. But we no longer need to worry about it because, as we'll see, this quantity is constant. So if you recall, the slope of a line is just the change in whatever's on the y-axis divided by the change in whatever's on the x-axis. In the context of this supply and demand diagram, the slope is just going to be a change in price divided by change in quantity. So we could ask ourselves, what is the slope of this demand curve? Well, to see that, it would probably be helpful to write our demand curve in terms of price as a function of quantity. In other words, to write down our inverse demand curve. So we could do that just simply by solving for P. We could say 4P equals 400 minus quantity demanded, or P equals negative 1/4 quantity demanded plus 400. So if we were going to think about the slope of our demand curve here, well, we notice we have something of the form y equals mx plus b, and then the slope is just this m. So we could say that the slope of our demand curve is just negative 1/4. So here, if change in P divided by change in Q is 1/4, then it stands to reason that the change in Q divided by the change in P, which is the reciprocal of this guy, is just negative 4. And then we could just go ahead and plug this in to what we see here to get a number. And we could say that our elasticity of demand is just negative 4 times the price at the equilibrium, which we said was 60, divided by the quantity at the equilibrium, which we said was 160. And we just go through some math here and notice that this is just negative 4 times, what do you get down here? So 6 over 16, which is 3 over 8. So just negative 4 times 3 over 8, which is negative 12 over 8, which is the absolute value of negative 1.5. So we just get 1.5 as our price elasticity of demand at this equilibrium point. Notice here we didn't have to artificially construct a second point because we could use the algebra that we did here to solve for the slope of the line and just plug that in at this point in the equation. Alternatively, you could in fact just choose an arbitrary price, figure out what the corresponding quantity demanded would be, and then actually calculate percent change in quantity demanded divided by percent change in price to get the elasticity. And what you would get is an approximation of this 1.5 figure that we see here. Now, if that's the approach that you feel like you should be taking, there are a few things that you want to keep in mind. The first most obvious thing is that the 2 points that you're comparing have to both be on the same demand curve. So we're just going along the demand curve. You don't want to do something silly like take the equilibrium point here and then accidentally take a point on the supply curve or something like that. Elasticity of demand just measures changes along the same demand curve. The second thing is that you want your second point that you're comparing to be pretty close to that equilibrium point, because the approximations that you'll get will get closer and closer to this 1.5 figure as this distance gets smaller and smaller. So if I was going to choose another price here, I might choose 59 or 61 or something like that. I wouldn't try to calculate the elasticity between this point and like this point all the way down here. So make sure your points are pretty close together and you'll get a closer approximation to this exact figure here. The third thing that you would want to be aware of is if you're using the formula that's talking about 2 points explicitly, you want to think about whether you're using this formula here or whether you're using the midpoint method for calculating elasticity, which you can find in one of the earlier videos on this topic.